To solve this system of nonlinear equations, I think I'm going to use the substitution approach. So I'm looking at the second equation. I can solve it for either x or y and put that information into the first equation. I think I'm going to solve it for x, which I'll enter in here just because I see this 2 in front of the y squared. I don't think that's extremely important, but it's just the first thing that jumps out at me. So the second equation is really equal to, so we have x is 3 minus y. I'm now going to put that x right here. So if we restate the problem, it's really 3 minus y squared plus 2y squared is equal to 9. This is the equation that we want to solve. So we have to square this thing out. I think I'll just do that off to the side. So if you do 3 minus y squared, well, that's 3 minus y times 3 minus y. So we'll have to FOIL. If we multiply in the 3, we get 9 minus 3y. If we then multiply in the negative y, we get another minus 3y, but a positive y squared. Combining the negative 3y's gives me negative 6y. So that's what this piece here is going to be equal to. It's going to be equal to 9 minus 6y plus y squared. Well, then we also have this plus 2y squared that's already sitting here, and that's equal to 9. So now it comes to combining like terms. So on the left side of the equation, well, I have a y squared and a 2y squared. I'm going to put that first, but we have a total of 3y squared. We have minus 6y, and then we have a plus 9, and that still is equal to 9. I can subtract 9 from both sides of the equation, which just cancels it on the left and the right, and we're left with 3y squared minus 6y is equal to 0. To solve this thing, I'm going to factor it. And the approach I'll use is taking up the greatest common factor. I guess the greatest common factor is, well, I can take out a 3 and a y, and what's left over is y minus 2. Because if I multiply this back into both terms, it'll take me back to 3y squared minus 6y. I have two factors that I can set equal to 0. One of them is, well, where is 3y equal to 0? And where is y minus 2 equal to 0? Well, the very first equation, 3y equals 0, means, well, y has to be equal to 0. And if y minus 2 is equal to 0, that means y is equal to 2. Now, these are just the y coordinates. We also need their corresponding x values. That's where I'll use this equation. So to do this, let's see. I'll first say, if we're working with y is equal to 0, so if we're working with that, x is equal to 3 minus 0, and therefore, well, x is equal to 3. Altogether, this is the point 3 for x and 0 for y. This is one of the solutions to the system, 3, 0. And if you want, you can plug that into both equations. Certainly works in the second. And it also works in the first equation too. Just, not necessary, but just a quick check. Now, if I check out y is equal to 2, okay, in the equation x is equal to 3 minus y, we have that x is equal to 3 minus 2, and therefore x is equal to 1. And this is the point 1 for x and 2 for y. And again, you can plug this information into both equations in the original system to see if they work. And let's see. In this equation, we'd have 4 times 2 is 8 plus 1 is 9, and 1 plus 2 is 3. Yeah, here are my two solutions, 3, 0, and 1, 2.